Good morning everyone. Welcome to today's maths class. Today we are going to continue the problems from the exercise 9.1 of the chapter Applications of Trigonometry. Okay, we are at the seventh problem. Okay, from a point on the ground, the angles of elevation of the bottom and the top of a transmission tower fixed at the top of a building, 20 meters high building, are 45 degrees and 60 degrees respectively. Okay, find the height of the tower. Now look at this. See, elevation of the bottom and the top of a transmission tower. Now look at this. Here I have drawn the diagram. Here there is a building of height 20 meters and there is a tower, cell tower on the top of the building like this. When the observer observes from a point, if we look at the bottom of the tower, the angle so formed is 45 degrees. And when he looks at the top of the tower from the same point, the angle increased and it was changed to 60 degrees. Okay, so at first when he observes the bottom of the tower, which is at the top of the building, is 45 degrees, makes 45 degrees. When he looks at the top of the tower, he has to raise his neck, so the angle will be increases. So that angle change it to 60 degrees. Then we need to find the height of the tower. This height we need to find. Let us take this height as x. That x we need to find. Let us draw the geometric figure for this data. Here, let us take the building stands vertically on the ground. It is common. Now, the tower, see the building height is given as 20 meters. The building height is given 20 meters. Let us take the height of the tower which is unknown as x meters. Okay, from the observer point of observation, let us take it as O, and this is A, this is B. Otherwise take the building as B, AB, and this is C. When he looks at the point B, the angle is 45 degrees. Okay, and when he looks at the top of the tower, the angle increases to 60 degrees. Okay, now we need to find the height of the tower. This is the information we got from the problem. Let us do the problem. Now, height of the building. How much it is given? Is equal to 20 meters, and let the height of the transmission tower is equal to x meters. Angle made by the observer when he looks at the bottom of the tower is 45 degrees, and when looks at the top, angle is 60 degrees. So I have gathered all the information of the problem. Now let us solve this. I am erasing this rough diagram. Now look at the geometric diagram. Here we have two right angle triangles. In that I have taken first, I am going to take the triangle OAB. We have to take tan. Actually, this distance we don't know. Let us take it as d meters. Okay, the distance from the observer to the building, which is not given, I have taken it as D. Okay, now I will take tan theta. What is the tan in triangle OAB? AB by OA. So what is the angle given? Theta is equal to 45 degrees is equal to AB value 20. By OA value I have taken as D. Tan 45 is 1. So 1 is equal to 20 by D is equal to, by taking D into LHS we get D is equal to 20 meters. Therefore, we have got the value of D, which is the distance from the observer to the bottom of the building. Okay. Now, by using this, we are going to find the height of the tower. Now, let us go with the next triangle. In triangle OAC. Now take tan. Tan theta is equal to. Now in the entire big triangle, tan, if we have taken tan, the opposite side is, for 60 degrees opposite side is AC and adjacent side is OA. Now what is the angle in the big triangle? 60 degrees. Tan 60 degrees is equal to AC. What is AC? That AC means total height. The building height plus tower height. 20 plus X by OA. OA is D. Now look at this. Tan 60 degrees is root 3. Is 20 plus X by D from 1. From 1 you see, what is the D value? D value is 20. So let us take the 20 from the denominator to LHS, we get 20 root 3 is equal to 20 plus X. Therefore, X is equal to 20 root 3 minus 20. Now, let us take 20 common, 20 into root 3 minus 1 meters. So, this is the height of the tower. So, let us write here, therefore, height of the tower is equal to, what is the height of the tower? 20 into root 3 minus 1 meters. As the root 3 value not given, we can leave the answer like this. Okay. Now look at the 8th problem. A statue 1.6 meters tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degrees, and from the same point, the angle of elevation of the top of the pedestal is 45 degrees. Find the height of the pedestal. Okay. Now, here you look at the diagram. Look at the picture. Here, the height of the pedestal is given. This height is, look at the picture. Statue, 1.6 meters height. Statue is given, but the pedestal height is not given. That we need to find. This height we don't know. Let us take it as H, which is not given. Okay, so pedestal means a base of a statue. The base height is not given, but statue height is given. When an observer looks from a point and observes the top of the pedestal, the angle so formed is 60 degrees, and from the same point if he observes the top of the pedestal, that means the bottom of the statue, both are same, then the angle is 45 degrees. The total angle is 60 degrees, and when he looks at the bottom of the that is statue, that means the top of the pedestal, the angle is 45 degrees. So this is the information. Let us draw the geometric picture for this data. So let us take this AB as the pedestal, and this is the statue. The statue we have taken as BC. Okay, now this is a right angle obviously, and when you look at this point, the angle is 45 degrees. Okay, when you look at the top of the statue, the angle so formed is, how much it is? 60 degrees. This is 60 degrees. Okay, and the height of the statue is not given. Statue is given. How much it is? 1.6 meters. But the height of the pedestal is not given. That we need to find. Question mark. Okay, this is the information from the problem. Let us answer it. Okay, now first of all we need to take the information from the problem. At this point I am taking as O, observer, and let us take this distance as d meters. Okay, now this is the 8th problem. Height of the statue is equal to 1.6 meters. Okay, angle formed when observes the top of the statue. How much? 60 degrees. In the same way, angle formed when observes the bottom of the statue is equal to 45 degrees. Okay, and let the height of the pedestal is equal to h meters. So we have taken the height of the pedestal is h meters. Okay. Okay. Now see here we have got two right angle triangles and the distance, the horizontal distance, let the OA is equal to d meters. So this is the information. Now let us do the problem by taking two different triangles. The first triangle I am taking in triangle OAB. The small triangle, it is right angle triangle, okay? Here angle A is equal to 90 degrees. So we can apply any trigonometric ratio. Let us apply, why? Because here hypotenuse is not required. So whenever the hypotenuse is not required, it is not involved in the problem, either it is known value or unknown value, we can go with the tan. So let us take tan. Tan theta is equal to, what is the opposite side in the triangle OAB? OAB as per this angle, AB, adjacent side is OA by OA. So just to compare with the previous problem, in the previous problem, this height is given, this height, the building height is given, tower height was not given. But in this, the topper one, that means the statue height is given, bottom height is not given. It is same as the previous problem. Now, so tan theta, tan 45 degrees is equal to AB value is not given h by OA value, we don't know, that we have taken as d. So tan 45 is 1 is equal to h by d. This implies if you take d into LHS, we get d is equal to h. So let us take it as 1. That is the first equation. Shall I erase this? Now, let us go with the next part, next triangle. In triangle OAC, what is triangle OAC? It is a right angle triangle in which angle A is equal to 90 degrees. And here, what is the angle formed in the big triangle? The total angle, look at the red mark angle, that is 60 degrees. Tan 60 is equal to opposite side AC by adjacent side is OA. What is tan 60? Tan 60 is root 3. And AC value means the pedestal height and the statue height, both together. So we have to take it as AB plus BC by OA value D. So this implies root 3 is equal to AB is h and BC is 1.6 meters. By D value from 1, D and H both are same, we proved. So from 1, okay, since from 1. Now, by D value we can take as D plus with H. By H if you take into LHS root 3, H is equal to H plus 1.6. Now, root 3 H minus H is equal to 1.6. Now let us go to the next step. If you take H common, H into root 3 minus 1 is equal to 1.6. Therefore, H is equal to 1.6 by root 3 minus 1. So we have to rationalize this. How to rationalize? Is equal to 1.6 by root 3 minus 1. Let us multiply root 3 minus 1 in the numerator and denominator. Then H is equal to 1.6 into root 3 minus 1. So this root 3 minus 1 into, here we need to multiply with root 3 plus 1. So root 3 minus 1 into root 3 plus 1. A square minus B square. Root 3 square, 3 minus 1. So the denominator becomes 2. Okay, then we get is equal to 0.8 into root 3 minus 1. So this is the height of the pedestal. Therefore, is equal to 0.8 into root 3 plus 1 meters. Okay, did you understand the problem? Now, look at the ninth problem. The angle of elevation of the top of a building from the foot of a tower is 30 degrees and the angle of elevation of the top of the tower from the foot of the building is 60 degrees. If the tower is 50 meters high, find the height of the building. Here you look at this. Here there is a building and a tower. The tower height was given. What is the height of the tower he has given? 50 meters? Yes, 50 meters. The building height was not given. So let us take it as H. H is unknown value. Okay, when you observe, see the angle of elevation at the top of the building from the foot of the tower. If you observe from the foot of the tower, the angle of elevation is this is 30 degrees. And in the same way, if you observe the top of the tower from the foot of the building, the angle of elevation is 60 degrees. Okay, this is the information from the problem. We need to find the height of the building. Okay, let us draw the geometric picture for the information he has given. So let us take the horizontal distance between the building and the tower. Okay, now look at this. This is the building I have taken. This is the height of the building. AB. Height is not given, so let us take it as H question mark. And see, look at this. This is the tower. This height is given 50 meters. Okay. Now this height is 50 meters. Now, if you observe from this point A to the point B, CD is the tower. The angle of elevation is 60 degrees. And if you observe from the bottom of the tower, if you observe the top of the building from the bottom of the tower, the angle of elevation is, how much it is? 45 is 45 degrees. Okay. Top of the building. Sorry, here the values we have taken. So let us check once again. The angle of elevation at the top of the building from the foot of the tower is 30 degrees. From the foot of the tower is 30 degrees. And the angle of elevation at the top of the tower from the foot of the building is 60 degrees. Now 30 and 60. We need to find the height of the building. So this is the information. Let us do the problem. Here this is 90 degrees and this is also 90 degrees because the building and the tower are perpendicular to the base. Okay. Now let us take the information from the diagram. This is the ninth problem. Height of the tower is equal to 50 meters. Okay, angle made by the observer to observe the top of the building, okay, is equal to 30 degrees, and the angle made by the observer to observe the top of the tower is equal to 60 degrees. And we have to take, let the height of the building is unknown. We have to is equal to h meters, which is not given. We need to find that only. And also we need to take the distance between these two. Let us take it as d meters. The distance between this tower and the building was not given. Let us take it as d meters. So now with this information we can solve the problem. We can find the height of the building. Here we have two right angle triangles. What are they? One is ABC and the other is ACD. So let us take the first triangle. In triangle ABC, what is the right angle? Angle A is equal to 90 degrees. Let us take tan. Already I told you why I am taking most of the times tan, because in these problems the hypotenuse is not involved. Okay, neither it was given nor asked. So we need to take the tan in such cases. Now tan, what is the tan angle? In the small triangle ABC, tan 30 degrees. 30 degrees. Opposite side is AB. By adjacent side is AC. What is tan 30? 1 by root 3. And opposite side H we don't know. And the adjacent side also we don't know. D. So let us cross multiply. D1j D is equal to root 3H. Say this is 1. So we have got one value of D in terms of H. Let us keep like this as the equation 1. Now I am going to erase this rough picture. For understanding purpose, I am drawing this type of pictures, but in the examination or in the classwork it is not necessary to draw these pictures. This geometry picture is sufficient to draw. Okay, this is only enough. This is not necessary. Only for understanding purpose. Now, let us take the big triangle, green triangle. What is that? In triangle ACD, you have to take tan. What is the angle formed in this triangle? 60 degrees. Opposite side CD, by adjacent side is AC. What is the tan 60 value? Root 3. And CD value was given 50 by AC value D. This implies root 3 is equal to 50 by. So actually D value we got in terms of H in the equation 1. Look at this. So from 1, okay, D value is root 3H. So this implies root 3 if you take to this side, root 3 into root 3H is equal to 50. Root 3 into root 3, 3H is equal to 50. Therefore, H is equal to 50 by 3. If you divide, so you get 16 2 by 3, mixed fraction. You can write like this. H is equal to 16 2 by 3. So what is the conclusion we need to write? What is this H value? Height of the building. Therefore, the conclusion is very important. You must write it. 16 2 by 3 meters. Okay, did you understand? Let us continue the remaining problems in the next class. Thank you. Have a nice day.